Chemical Reactions, Chapter 8, Practice Test A. It's a good idea to have out test-taking tools such as your periodic table with polyatomics on the back, your combination and decomposition helpful hints, and maybe some scrap paper so that you can make formulas without messing up your paper and confusing yourself and the teacher. One thing I'll suggest when we're doing these is make sure you're reading the directions carefully. We are going to be writing a complete balanced equation for the following combination reactions, predicting the correct product. And a complete balanced equation will have symbols letting us know what type of things are formed. Recommendation, since we're doing combination reactions and we have helpful hints, do yourself a favor, just write HH next to each one. Though the directions don't say to, if we identify which helpful hint, you're more likely to be steered down the right path. First one, number 1, says a magnesium metal reacting with iodine crystals. So I'm going to go to my helpful hints and start looking to see which one might be helpful on my combination. And the first one right away, when a metal combines with a nonmetal. This is obviously a metal. Iodine is over here, it's a nonmetal. Now I'm going to write my reactants. Magnesium is simply Mg. It's a solid because they called it a metal. It's going to be reacting with iodine, and iodine is one of those from the horse's neat oats for clear brown eyes family, which means that instead of just writing I, I'm going to write I2. It's a diatomic, and it's only found attached to itself if it's alone in nature. It's going to yield, now let me check my helpful hint number 1. When a metal combines with a nonmetal, use their oxidation numbers to figure out the product. In other words, it's an ionic compound. So the oxidation numbers, magnesium is a +2, iodine is a -1. When I crisscross those charges, it's going to form magnesium iodide. Then I have to check to see if it's balanced. And in this case, I'm seeing 2 iodines and 2 iodines, and I'm seeing 1 magnesium and 1 magnesium. I don't think I'm going to get out a T-chart. It looks balanced. So then what? Now I need to fill in some more things. Crystals are solids, and magnesium iodide is a type of salt, and that's also a solid. The next one, solid aluminum oxide reacting with water. Looking for a helpful hint. An aluminum oxide is a metal oxide. Look down the list. There's something about a nonmetal oxide, but metal oxides reacting with water. Do we have it reacting with water? Yes, we do. This looks like a helpful hint number 4. Now I need to write the correct formulas. Aluminum oxide. Aluminum is a +3. Oxygen is a -2. Crisscross those, and that's going to be Al2O3, and they told me that's a solid. Reacts with, so this is another reactant, H2O, which we'll call liquid. Make a yield sign. Go back to those helpful hint number 4. Helpful hint number 4 says, when a metal oxide reacts with water, it will produce a base. Even though we haven't been into bases much, we're starting to get familiar with the terminology, and they will end with the hydroxide ion, and it tells us it right there, OH minus. So when I'm trying to make the correct formula, it's going to be the start with the metal, that's aluminum, and that's +3. End with the hydroxide, that's OH, and that's a -1. When we crisscross that, we're going to have to take the hydroxide ion 3 times. AlOH taken 3 times. Now we have to check for balancing. And I can see very quickly that it's not, because I see 4 oxygens on this side and only 3 oxygens. So I'm going to go to my T-chart. aluminums, oxygens, and hydrogens. Count them up. There's 2 over here, 3 and 1 make 4, and then there's 2 of them here. And on this side we have 1 aluminum, 3 oxygens, and 3 hydrogens. Now I'll go down back from the top of the list and look down to see what doesn't match. Right now I'm seeing that there's 2 aluminums and only 1 aluminum on this side, so I'm going to need double the aluminums over here, so I'm going to put in a 2 as a coefficient, which is going to change this to 2. And it's also going to, and then I have to reevaluate my oxygens. I already had 3 times 2 gives me 6 oxygens. I already had 3 hydrogens times 2 gives me 6 hydrogens. Now the things that don't match on the reactant side are the oxygens and hydrogens, and they're conveniently linked to each other right here. So if I need 3 times as many hydrogens, I'll put a 3 out here, changing this to 6. Reevaluate my oxygens, 3 here and 3 here also make 6. That's a balanced equation. The only thing I would add is that this is now an aqueous solution because it was reacting with water. The next one, gaseous sulfur trioxide reacting with water. What is sulfur trioxide? Since I see prefix, it's SO3 reacting with H2O. Sulfur is over here in the nonmetal side, so we have a sulfur nonmetal oxide reacting with water, and it will produce an acid. So that's helpful hint number 3. Helpful hint number 3. This was gaseous, this is liquid. When I add these together, it said on my helpful hints, it said to start with the H and end with the O. We actually have 2 H's, then an S, and 3 plus 1 makes 4 oxygens. Sulfuric acid, that is going to be aqueous because it's in water. Number 4, the white powder phosphorus reacting with oxygen from the air. Phosphorus is P. It's an element and it's a nonmetal. Oxygen is also a nonmetal. When I check my combination helpful hints, it has one about 2 nonmetals combining. That's helpful hint number 2. And when they do so, you just simply don't know for sure what its product is going to be, so I'm going to look for more information. Forms a yellow powder of diphosphorus pentoxide. So this one actually tells me without me having to predict what the product will be. I just have to write things correctly and balance it. Phosphorus is not diatomic, but oxygen is. It's going to form diphosphorus P2 pentoxide O5. Phosphorus is a powder, so that's a solid. Oxygen from the air is a gas, and when we're done we're going to get a powder, which is a solid. The only thing left is to check how many we have, and the quick obvious thing that I see is there's more phosphorus and oxygen on this side than this side. A quick T-chart. P's phosphorus and oxygens. Right now there's 1 and 2. On the other side there's 2 and 5. The obvious thing that I see is doubling this isn't going to help tripling. The only thing we can do is make them both 10 on each side so that they'll match. So if I make this 2, that's going to change this to 4 and this to 10. But now I need 4 of these on this side. Double checking, and it is balanced. And the last one in this section, a copper metal reacting with sulfur powder forms a copper 1 product. Let me check which helpful hint. First one says a metal. I got copper. That's a metal. Combines with a nonmetal. Sulfur powder is a nonmetal. Yep, use their oxidation numbers. This is a helpful hint number 1. Copper is Cu. plus sulfur is S, and it's going to give us a copper 1 product. So what that means is when I'm crisscrossing my charges, I have to make sure that I'm assigning a plus 1 to the copper. Sulfur is in the -1, -2 position. And when I crisscross, Cu2S. Next thing to do is to check to see if they're balanced. And this is one I'm not even going to make a T-chart. I can see I have 2 coppers over here, and I'm going to need 2 coppers over here. And that makes this one balanced. Last thing I should do, copper metals are solid. Sulfur powder is also a solid. The copper 1 product, a solid and a solid in this case, will make a solid.